Most people have never heard of these machines, and there's a good reason for that. They don't get parked in showrooms, they don't appear in advertisements, and they definitely don't fit on a regular highway. Some of these giants take several days just to put together, and when they finally get moving, the ground around them literally trembles under the weight. These are the machines that operate far from public view, buried deep in open pit mines, tunneling under cities, and reshaping entire landscapes, one massive load at a time. Today, intense industry is pulling back the curtain on the largest industrial machines ever constructed by human hands. These aren't just big, they are record-breaking, earth-shaking, engineering landmarks that most people will never see in person. And the last one on this list, it officially holds the title of the largest land-based mobile machine ever built on Earth. So stick around until the end, because that final reveal changes everything you thought you knew about the word massive. Crest Coal Hauler, deep inside coal mining operations across the United States, there's a vehicle that most people have never heard of, yet it carries more raw material in one trip than dozens of standard trucks combined. That's the Crest Coal Hauler, manufactured by Crest Corporation, a machine purpose-built for moving enormous quantities of coal inside open-pit mine sites. Measuring 43 feet, 13 meters in length, and standing nearly 16 feet, 5 meters tall, this hauler tips the scales at around 200,000 pounds, 90 metric tons, before a single piece of coal is loaded. Once fully loaded, that number doubles. The Crest can carry over 400,000 pounds, 180 metric tons, making it one of the most capable coal transport vehicles on the planet. At the heart of the machine is a Caterpillar V16 engine displacing roughly 1,650 cubic inches, 27 liters, and producing 1,200 horsepower. That level of output isn't just impressive, it's necessary. Getting a fully loaded hauler moving up a steep mine incline demands massive torque, and this engine delivers exactly that. The drivetrain relies on a heavy-duty automatic transmission paired with rear-wheel drive, backed up by a reinforced hydraulic suspension system built to soak up the abuse of broken, uneven mine terrain. Visually, the Crest is hard to forget. Its curved dump bed is engineered to squeeze every possible ton into each load. The operator's cab is mounted to the side for maximum sight lines, and the tires, standing 10 feet 3 meters tall, look like they were taken straight off a monster tractor. The machine moves material between extraction zones and processing areas, and a single Crest unit can replace entire fleets of smaller trucks. One last detail, some mining operations actually name and paint their units with custom designs, treating them like unofficial team mascots of the mine. Komatsu D575A3SD. If the Crest Coal Hauler is built to carry, this next machine is built to push, and nothing pushes like the Komatsu D575A3SD, the largest crawler dozer ever manufactured. Engineered in Japan for the most demanding mining and earth-moving operations on the planet, this machine measures 38 feet, 11.7 meters in length, stands 16 feet, 4.9 meters tall, and swings a blade that's 23 feet, 7 meters wide. Its empty operating weight is over 335,000 pounds, 152 metric tons, and watching it move feels like watching a steel wall advance across the earth. Power comes from a Komatsu SA 12-volt 170 EV12 engine displacing 2,800 cubic inches, 46 liters, and generating 1,150 horsepower. With that behind it, the D575A3SD can push through 90 cubic yards, 69 cubic meters of material in a single pass, more than a full room full of compacted dirt gone in one sweep. The automatic transmission is tuned for long gear ratios, keeping sustained heavy-duty torque available across the full range of terrain it faces. Crawler tracks with a rigid suspension system give it superior stability on rough ground. This machine looks exactly as aggressive as it sounds. The sheer size of the blade means ground crew members are needed to guide it during tight maneuvering, and the low constant engine rumble gives the impression that nothing could stop it. It's typically deployed in large coal mining operations across the United States and Japan, where it regularly handles work that would otherwise require several smaller dozers operating simultaneously. It's also used to level large tracts of remote land with speed and precision. At a trade expo in Texas, one D575A3SD unit arrived for display, and it took a full 2 days just to unload it from transport. Caterpillar 797F, climbing into the cab of this next machine is not like getting into a truck. It's more like walking up to the second floor of a building. The Caterpillar 797F is one of the largest mining haul trucks in the world, engineered by Caterpillar in the United States and deployed across some of the biggest mine sites on Earth. It stretches 49 feet, 15 meters in length, stands 23 feet, 7 meters tall, and reaches nearly 33 feet, 10 meters wide with the mirrors extended. Total loaded weight exceeds 1.5 million pounds, 687 metric tons, and even when empty, it still weighs over 575,000 pounds. 260 metric tons. Under the hood sits a Caterpillar C175 20V20 engine displacing 6,488 cubic inches, 106 liters, and producing a staggering 4,000 horsepower. Power moves through a 7-speed automatic transmission, fine-tuned for uphill hauling and rough cross-terrain travel. Rear-wheel drive is supported by a heavy-duty suspension system and electronically managed braking handles the serious forces involved in descending steep mine grades. The 4 main tires stand nearly 13 feet, 4 meters tall, and cost as much as a small car each. The dump bed handles up to 400 tons of payload per load. To move the same amount of material, you need approximately 40 standard dump trucks making the same trip. The 797F is a workhorse in iron, copper, and coal mines worldwide. It's become so well known in the industry that it's shown up in mining documentaries, equipment exhibitions, and even professional simulators. At one Canadian operation, operators have a saying about the 797F: you don't drive it, you command it. BELAZ 7571 DO. Coming straight out of Belarus, the BELAZ 7571 DO arrived on the scene and completely reset what people thought was possible in haul truck design. Built by BELAZ, this is the largest and highest capacity mining dump truck ever made in both size and payload. The numbers are hard to fully process. 67.5 feet long, 20.6 meters, 26.5 feet tall, 8.1 meters, and 32 feet wide, 9.7 meters. Empty, it weighs around 793,000 pounds, 360 metric tons. Loaded, it carries up to 992,000 pounds, 450 metric tons of material, bringing total moving mass past 800 tons. 2 MTU V20 diesel engines power the BELAZ 7571 DE, each producing 2,300 horsepower for a combined output of 4,600 horsepower. But the power doesn't go directly to the wheels through a traditional drivetrain. Instead, both engines feed a diesel-electric system with 4 electric wheel motors providing independent propulsion to all 4 axles. The result is 8x8 all-wheel drive paired with an advanced electronic transmission and hydrop pneumatic independent suspension, a setup that handles extreme loads with a level of control that seems almost impossible at this scale. The operator's cab sits mounted to the side of the structure and looks almost comically small compared to the rest of the machine. The tires are nearly 13 feet tall, and the staircase leading up to the cab climbs 3 stories. Even the fuel tank is oversized, holding more than 1,300 gallons, 5,000 liters. The BELAZ 757 DE operates across large open pit mines in Kazakhstan and Russia, where it routinely replaces entire fleets of smaller haul trucks. In 2014, it officially received a Guinness World Record as the world's highest capacity haul truck, a record that still hasn't been beaten. Hitachi EX8000-6. When the goal is moving outrageous amounts of rock and earth in the shortest time possible, very few machines in existence can compete with the Hitachi EX8000-6. Built in Japan by Hitachi Construction Machinery, this is one of the largest hydraulic excavators ever produced, engineered specifically for the world's most intensive mining environments. It stretches 49 feet, 15 meters in length, rises over 33 feet, 10 meters tall, with the boom fully raised, and weighs approximately 1.78 million pounds, 811 metric tons. Its ground footprint is larger than a full basketball court. 2 Cummins QSK 60-volt 16 engines combine to produce 3,880 horsepower, giving the hydraulic arm the force to lift around 59 cubic yards, 45 cubic meters of material per pass, roughly 75 tons at a time. The machine operates on a hydrostatic transmission with independent hydraulic circuits, providing smooth, powerful, controlled movements even under continuous heavy loads. Wide crawler tracks and a reinforced chassis suspension handle the weight and constant impact of non-stop operation in harsh conditions. The bucket is wide enough to fit 2 full-size cars sitting side by side. The operator's cab is fully enclosed, climate-controlled and sound-insulated, with bulletproof glass and a full suite of digital controls. The EX8000-6 is deployed in large copper, gold, and coal mines across Canada, Australia, and Chile. In certain operations, it fully loads 300-ton haul trucks in just 4 to 5 passes, compressing what used to take hours into minutes. One unit was even modified with specialized hydraulics to resist corrosion for use inside a lithium mine, a technical adaptation that has since become a documented industry case study. If you're enjoying this content, hit that like button, subscribe to Intense Industry, and turn on notifications. There's a lot more coming. Bucyrus 495HR. Some machines don't just get the job done. They define what the job looks like for everyone else. The Bucyrus 495HR, built by the legendary Bucyrus International in the United States, is one of those machines. An electric rope shovel that became an icon in large-scale surface mining. It stands approximately 50 feet 15 meters tall at the boom, stretches nearly 100 feet 30 meters in length, and weighs over 2.8 million pounds, 1,270 metric tons. This machine doesn't move mountains as a figure of speech, it moves them literally. Rather than a combustion engine, the 495HR runs entirely on electric power delivered through high-voltage cables. Its massive electric motors drive 3 distinct systems: hoisting, swinging, and digging, each operating with industrial-level precision and timing. The bucket can pull up to 120 short tons, 109 metric tons, in a single scoop. It rides on enormous crawler tracks, each wide enough to support the weight of a freight locomotive, with hydraulic systems balancing the structure throughout the excavation cycle. The front bucket holds up to 157 cubic yards, 120 cubic meters of material, and the boom extends over 100 feet, 30 meters. The visual effect is like watching a mobile tower pick apart the earth. The high-mounted cab gives the operator full visibility and is packed with precision controls. The 495HR has been used in coal and iron mines across the United States, Canada, and South Africa. Even after Caterpillar acquired Bucyrus in 2011, many of the people who work with these machines still call it by the original name, with a certain amount of pride. One unit in Wyoming has been running for over 2 decades with only minimal upgrades. Komatsu P&H 4800 XPC. The Komatsu P&H 4800 XPC is the largest electric rope shovel Komatsu has ever manufactured. Designed and assembled in the United States, it is one of the biggest single pieces of mining equipment operating anywhere on Earth. With the boom raised, it stands over 100 feet, 30 plus meters tall, spans nearly 65 feet, 20 meters wide, and weighs in at over 3 million pounds, 1,400 metric tons. From a distance, there's a genuine risk of mistaking it for a stationary industrial facility. It runs entirely on electric power, with large motors fed directly from grid-connected cables. At close to 10,000 horsepower, the shovel's lifting, crowding, and swinging mechanisms operate with precision that feels almost impossible at this scale, even in the most punishing mine environments. The star of the machine is its bucket, capable of lifting up to 135 short tons, 122 metric tons, in one swing. That's enough material to fill a 6-story building with dirt and rock in seconds. Industrial-scale crawler tracks support the structure, and an advanced shock absorption system reduces stress on the frame during repetitive digging cycles. The rotating base keeps the machine balanced at all times, and the elevated operator cabin includes automated controls, redundant safety systems, and 360-degree monitoring for continuous operation. The 4800 XPC runs in coal and copper mines across the US and Canada, regularly operating for up to 22 hours a day with minimal downtime. One particular unit was painted in red, white, and blue and given the nickname Liberty, a tribute to American industrial engineering. WSDOT Bertha, SR99 TBM. Some machines don't work in open mines or remote quarries. Some of them go underground straight through the foundations of living, breathing cities. That's exactly what Bertha was built for. Commissioned by the Washington State Department of Transportation, WSDOT, and designed by Hitachi Zosen in Japan, Bertha was a tunnel boring machine, TBM, tasked with digging a new highway route beneath downtown Seattle, the SR99 tunnel, nearly 2 miles, 3 kilometers, through one of the most complicated urban environments in North America. At the time of her launch, Bertha held the title of the world's largest TBM by diameter, 57.5 feet, 17.5 meters wide, 330 feet, 100 meters long, and weighing over 7,000 tons. She wasn't just a tunnel digger, she was a fully self-contained underground factory. 25 electric motors generated over 8,000 horsepower to spin a massive cutter head lined with hardened steel discs and blades capable of grinding through rock, soil, clay, and reinforced concrete. Hydraulic thrust cylinders and guide rails pushed her forward inch by calculated inch. Inside Bertha's hull were control rooms, electrical and mechanical equipment bays, conveyor systems for pulling debris back out, ventilation infrastructure, and rotating work crews operating around the clock. As she advanced, she simultaneously installed reinforced concrete tunnel segments behind her, constructing the permanent roadway in real time. The precision required was extraordinary, working beneath active buildings, highways, and water mains without causing disruption above. Bertha completed her mission in 2017 and was then dismantled. But the story didn't end there. Parts of the machine were turned into public art installations and are now on permanent display in Seattle's parks, a lasting tribute to one of the most ambitious infrastructure projects in the city's history. Bucyrus Erie 4250 No-Top, Big Muskie. If there was ever a machine that embodied the phrase largest ever built in its era, it was Big Muskie. Manufactured in 1969 by Bucyrus Erie in the United States, this electric dragline excavator carried that title for decades, and it's still talked about with reverence today. Big Muskie measured approximately 500 feet, 100 feet meters in length, stood 70 feet, 22 meters tall at the cab, and carried a 310-foot, 95-meter boom. Total operating weight exceeded 13,000 tons, roughly equivalent to the combined mass of two small aircraft carriers. Power arrived via high-voltage electric lines feeding a series of motors that together delivered more than 18,000 horsepower. These motors controlled the hoisting and swinging systems that manipulated the dragline bucket, and that bucket was something else entirely. Nearly 222 cubic yards, 170 cubic meters of capacity, around 295 tons of material in a single scoop. One clean pull and a massive layer of overburden was gone. Mobility was deliberately limited by design. Big Muskie repositioned itself using giant walking pads, massive flat structures that functioned like tracked feet, moving slowly around the mine floor. Some repositioning moves took multiple days to complete. From a distance, it looked far more like a power plant that had grown legs than any kind of construction machine. Operators reached the control cabin by moving through internal staircases and walkways built into the structure itself. Big Muskie worked Ohio's strip mines for decades, stripping back enormous overburden layers to expose buried coal seams. Over its working life, it moved an estimated 600 million tons of earth. When it was decommissioned in the 1990s, most of the machine was scrapped, but its bucket was preserved and now stands as a public monument, a permanent reminder of American industrial ambition at its peak. TAKRAF Bagger 293, and then there's this. The machine that sits at the very top of the list, not just on this channel, but in recorded human history, the TAKRAF Bagger 293 is officially the largest terrestrial mobile machine ever built. Manufactured in Germany by TAKRAF in collaboration with Siemens and completed in 1995, it was constructed to mine lignite, brown coal, in some of Europe's largest open-pit operations. The dimensions are almost too large to picture: 738 feet long, 225 meters, 315 feet tall, 96 meters, and a total weight exceeding 31 million pounds, 14,200 metric tons. Just moving it from one part of the mine to another can take several days. The Bagger 293 is a bucket wheel excavator. At the front of the machine spins a massive rotating wheel fitted with 18 individual buckets, each holding 8.6 cubic yards, 6.6 cubic meters of material. Together, they allow the machine to extract up to 8.5 million cubic feet, 240,000 cubic meters of earth every single day. It runs entirely on electricity, supplied through on-site high-voltage systems, distributing a total of 16,500 horsepower across multiple motors. A system of tracked undercarriages and precision steering mechanisms allows it to move across the mine floor in a slow, deliberate glide. Inside it houses technical rooms, maintenance corridors, and equipment stations. The interior feels less like a machine and more like a small industrial facility that happens to move. Operators work from an elevated cockpit with panoramic views and digital command systems that coordinate everything from the excavation process to the conveyor systems running across the structure. Today, the Bagger 293 continues its work in Germany's Hambach, open pit mine supplying lignite to nearby power plants that feed electricity to entire regions of the country. It has also become a cultural landmark, appearing in documentaries, international engineering exhibitions, and even as the centerpiece of a large-scale nighttime art performance, complete with light shows and live music. With the Bagger 293, we've reached the absolute ceiling of land-based industrial scale. Nothing moves more material on the surface of the earth. Nothing comes close.